And then, like I said, you could also do trapezoids if you wanted, because trapezoids will fit it even better. Okay, so let me put the picture back up. Okay, so with midpoints,
This almost looks like a better estimation.
yes, midpoints always give you a better estimation, even with a few rectangles.
And I think they're always the messiest geometrically too.
When you want that one a little taller again? You want your midpoint to hit the line?
Oh yeah, I'm sorry.
I was assuming,
Yeah, no, I know, yeah. Okay. I think the first one I kind of got
Yeah.
it, but then let's see, here's our 10.
Yeah.
Okay, so as you guys noticed when we first started drawing, that the midpoint is, the midpoint to be a little bit better. The midpoints are always going to give you a better estimate than right or left. And so, I mean, when you send n to infinity, algebraically it does not matter. But if you were trying to get a better estimate and you were going to use a discrete number of rectangles, discrete meaning a countable, discrete and finite. Discrete means countable, finite means it ends. So if you're going to use a finite number of rectangles, midpoints are going to give you a better estimate than using right or left. When you take the limit as n goes to infinity, they all turn out to be the same, because as n gets higher, the width gets smaller, and my left and my right start moving toward the middle point anyway, okay? And so you're going to get the same algebraic answer whether I work this out, or whether I work this out, or whether I work out the midpoints. But why it's still beneficial to maybe use midpoints is you do get a better estimate. You can use a lower number of rectangles, so if you are writing a program to get a decent estimate on something like the calculator or Excel, midpoints are going to more quickly get you that answer. And so I think all of us kind of appreciate the fact that we hit the button and, before we can even blink, there's an answer. And so in terms of a programmer, you might want to go through the trouble of understanding how to program with midpoints, because you'll get an answer quicker in fewer number of electronic steps. Okay, so we're summing. The width is still going to be the same. It's still going to be 10 over n, okay? Because my rectangle goes from 0 to 2. This one goes from 2 to 4. This one goes from 4 to 6. The rectangles are still stretching from the same points. And so 10 minus 0 divided by 5 is still giving me that same width. The height is given by the function, but now with the midpoints plugged in. So the first midpoint was the number 1. The second midpoint was the number 3. The third midpoint was the number 5. The fourth midpoint was the number 7. And the fifth midpoint is the number 9. So once again, we're trying to come up with a pattern for these 5, but then we'll generalize it. And there's probably more than one way to do it, but notice that
2n plus 1.
Yeah, like if I start at 1, like 1 is my first midpoint, okay? So I start at 1,
Then you go 3.
and then I keep adding
2.
2 to that to get the others. so I think, let's test this. 1 plus 2 times 1 minus 1 is equal to 1, right? 1 plus 2 times 2 minus 1, 2 minus 1 is 1, and 1 plus 2 is 3. And then 1 plus 2 times 3 minus 1, 3 minus 1 is 2, 2 times 2 is 4, 4 plus 1 is 5. And then 1 plus 2 times 4 minus 1, 4 minus 1 is 3, 3 times 2 is 6, 6 plus 1 is 7. And then the last one, 1 plus 2 times 5 minus 1 is 1 plus 8, which is 9. Okay, so what did we do there? Well, we took 1, which was my first midpoint, but I'm gonna, in our general formula, we're actually gonna have to adjust that also. Okay, so for the moment, I'm gonna hit the plus, and we'll talk about this in a minute. The 2 is my width, but in general, what's representing my width?
10 over n.
10 over n is representing my width. Okay, so 10 over n is the 2, and then we have I minus 1. And I'm running out of room here. Because then we want that squared plus 7, and we need to have a little discussion about what to fill in here. The 1 is unique to using 5 rectangles. If my rectangle went from 0 to a 10th, 1's certainly not going to be the midpoint of it. So this 1 is actually the width cut in half, and technically it's 0 plus the width cut in half, 0 being my starting point. Okay, so it's like I pick where I'm starting and then I add half of a width.
5 n.
So we need another variable here now?
So no,
No,
you're just gonna be 5
it's
n.
just gonna be
5
5
n.
over n,
Yeah.
yeah. The 2 canceled into the 10,
I
you
just
get
wonder
the
if you
5.
need a variable for starting points now.
Oh, no. Well, no, because it'll be a number. You'll,
Always be a number.
like, if you started at 5, it'll be 5. If you, like, if my graph, well, here, I'll just, we'll do this. Let's say I only wanted the area from 4 to 10, then I would start at 4. I mean, you could make it a variable if you were really generalizing it, but for pretty much any problem we're gonna see, you'll know where you're starting. Okay, so there is my midpoint formula. I is going from 0 to n. If we really want the expression for the exact, then you're thinking about the number of rectangles going to infinity.
There's an open parenthesis. Just
Well,
wondering,
okay, these two are multiplying by that.
is
This is for the square.
Is that 10 over n times
I minus
I minus
1.
1? Is that both supposed to be squared, or is that
That,
just the I
this
minus
whole, this whole thing, this whole entire
1?
expression,
It's supposed to be squared? Okay.
yes, because it's giving you the x value that's telling you your midpoint.
Oh, yeah, makes sense.
Yeah, that whole thing, yeah, Cameron.
Would it have been easier to use 2i minus 1
Um,
and then
2i minus
have the,
1.
uh,
Yeah, you could. The only reason I didn't go there, because I was trying to build the pieces in general. So like, given any function, given any function, what are the pieces that go together to build it?
so the 2i minus 1 would have only applied if you
So
used
if, well, one, it would have, yeah, exactly.
And it wouldn't have been
Exactly.
2, it would have been 10i over n minus 1, that would have been?
Well, no, I think he's stating something correct, but only if we were using 5 rectangles.
Not in general.
Yeah, but not in general. And actually, this you could even clean up differently too. So Cameron, I guess my general answer is, if there's a way that you want to clean it up, that's fine. I mean, there certainly are ways to clean it, because this would be 10n times I minus 10 over n, and then these both have the same denominator, so you could write it as 10 over ni minus 5 over n. I mean, that's simpler and cleaner. So you could replace what I have with that, and that would be accurate also. Okay, well, why don't you guys take about a 10-minute